So today we're starting chapter 3. This is going to be about exponential functions, and then later we'll talk about logarithmic functions. So today we're starting out graphing exponentials and then looking at those functions, how can you write them. So as a kind of warm-up, pause this video and think about which option you would choose. Would you rather receive $10 every single second for 24 hours, or do you want $1 and have what you have double every hour for 24 hours? So think about it, figure out how much you'd win for each. Okay, so you should pick option B because you're going to get a lot more money because you're doubling, you're doing some exponential growth. So if we calculate this out, if you're receiving $10 every second for 12 hours, so there's 60 seconds in a minute, 60 minutes in an hour, and then 24 hours. If you multiply that out, you'll get $864,000, which doesn't sound too bad. The next option, you're getting $1, and then it doubles, so you're multiplying by 2 every hour. So there's 24 hours, you multiply by 2 24 times, or 2 to the 24th. Multiply this out, you'll get 16,777,216. So definitely a higher rate. So if you're ever in the situation where you're trying to pick a prize, you want to pick the one that is exponential growth versus just like a linear, like straight multiplying. Life tip there. So what are exponential functions? This is their general form. You've probably seen this before. This a is your y-intercept. So like when x equals 0, y equals a, as a reminder. And then here, this a can't be 0, because if that equals 0, you multiply through, the whole equation disappears, and you just have 0, which is not interesting or helpful. B is the base. And this also can't be 0 for the same reason, then you just lose your whole equation and it doesn't help you at all. And B also has to be positive for this to work. And then the last thing is your exponent right here. So this is always going to stay as an x. Okay, so actual examples. Here's a graph. And we want to write out the equation of this function. So it tells us here that we have f of x equals b of x. We're going to start with that. And we need to figure out the b. So we have, I'm just going to write it as y equals b of x. And then we have this point right here. So that's an x and a y. You can plug those in and solve for b. So we plug that in, you'll get 8 equals b to the negative 3. And we need to get rid of that negative 3. So to undo a negative 3, we can raise it to a negative 1/3 on both sides. Because then you multiply these out, the 3's cancel, the negatives cancel, you get b to the 1. So 8 to the 3rd, you could do it by hand, or you can type into a calculator. You'll get a half equals b. If you did it by hand, you'd get 1/8 to the 3rd. Since it's a negative 1/3, you can put your number on the bottom. And then this would still give you 1/2. So to actually answer the question, we have to write this out. So y equals 1/2 to the x is your answer. Another one here, now we want our full form of a to the bx, but we have to figure out what is a, how can we figure that out? Remember, a is your y-intercept, so when x equals 0, we want to figure out what y is. So here y is 2, so a has to equal 2. So then we start off with y equals 2 b to the x, and now we can plug other things in. So you have an x here and a y here. So 18 equals 2 times b squared. Solve. And then we'll get technically b equals plus or minus 3 if we take the square root of both sides. But again, at the beginning, I said b has to be positive, so we can't use this negative 1. B has to just be 3. So you'll get y equals 2 times 3 to the x as your equation. Okay, so looking at this, we want to figure out how are each of these different from our 2 to the x function right here. So this is just standard transformations. We've done this before. But if we're doing 1 plus something, we're adding 1, you're going to go up 1. Here we're in with the x, subtracting 1, so we're going left to right. Because it's minus 1, we're going to go right 1. Here we have a negative, so that's some sort of flip. It's outside, not next to the x. This is going to be a vertical flip, or over the x-axis. And then here's our little negative in with the x, so this would be a horizontal flip. So same transformations, now we want to figure out what the graph looks like. Here's the original. And then remember this was moving up 1. So we want something that looks like this original, but is just up 1. So if you look at blue, that's not going to work, that's flipped. If you look at green, well, that's not up 1. This original goes through 1, 1 right here. And this is less than that, so it's not going to work. Purple's going down, so this one has to be the red one. Because it took the original and moved it up. So your A is now at 2. So then the next one, we said it was right 1. So we still want the same original shape, and the only one left is the green one. So this one has to be green. So that's the original shape. Next, we want to keep going. Now we have a vertical flip, which means we're going across the x-axis, so we're going in this direction. So you want something that takes this down to here. Well, that has to be purple. And then the only one left is the blue, but you could still figure it out because it's your horizontal flip, so it's flipping this way. So instead of going like this, we want to go like that. Okay, so then some stuff about e. So the natural exponent function is the one we use most often, and it has a base of e. In general, this is just called the exponential function. So when we talked about the 12 basic functions way at the beginning of the year, the exponential function was this. This is what e equals. It's kind of like pi. It keeps going on forever and ever and ever and ever. It's just a decimal that keeps going. So what is e? Some common questions about it. Where did it come from? So e is called the natural number because it comes or rises naturally in math and science when you do stuff. So this is technically what e equals. And this just kept coming up over and over and over again. So people decided to give it a name, like pi. They just call it e instead of having to write the limit as n approaches infinity of 1 plus 1 over n to the n over and over and over again. Where is it on your calculator? So it's kind of where your like pi usually is, but it's second in the division symbol. And then ln, which is your natural logarithm, is by your log button. So I'll show you that quick. If we jump over to the calculator, we'll have to accept. Okay, so here is e right there, right below the pi. So you do second, the blue button, divide to get e, and then your ln is right here underneath the log. So then what does it actually look like? Well, it looks like an exponential. You go through 1, 1 because your a is 1, and then you go up like an exponential function. Why is it called e and not something else? So Leonhard Euler discovered it, and people think he named it after his own name, but he says that e stands for exponential function. So we don't know exactly why it's e. It could be either one, or maybe a little bit of both. So here's your assignment. A note, this EOO means every other odd. So start with 15, skip 17, do 19. Skip 21, do 23. And that's it.